Would you believe me if I told you that the cosmos appeared exactly like it does now in the beginning? Surprising galaxies discovered by the James Webb Telescope, which probe the early universe, demonstrate just that things are more gentle out there. You're not as close to the energetic heart, so stars, planets, and life can form out there partially because of the material that the black hole has moved out there. The early universe resembled the modern one. This indicates that the Dark Ages were calculated incorrectly by our science. There must have been little more than heat, darkness, and unsettling particles during the time between the Big Bang and the emergence of the first complex galaxies. However, the cosmos we see now was completely constructed during this time period. What does this signify for astronomy and our science? Perhaps we are living through a revolution in astronomy and physics. All previous assumptions have been disproved by a single image taken with the new James Webb Telescope. Several galaxies in the image are so old that they shouldn't be there. However, our researchers now have to deal with the fact that they are genuine. There are currently tests being conducted on the Webb mission results. It remains to be determined by scientists if the light sources are indeed galaxies or something else. They must next verify that our earlier measurement techniques were accurate. The next important consideration is whether Webb was configured properly or whether something went wrong. We already know that the telescope is perfect. Additionally, the galaxy's ages have been verified. This leaves up the possibility that the redshift readings are not accurate. Experts, however, question this. It is far more likely that our Big Bang theories were incorrect. Galaxies that existed 13.5 or 13.6 billion years ago have been discovered by researchers. This would occur during the Dark Ages when galaxies were purportedly non-existent. Thus, scientists are witnessing fully formed galaxies that must have been several billion years old at the time of the discovery, rather than clusters of infant stars. The galaxies have amazing structures and forms that we are familiar with from modern galaxies. The possibility that dozens, if not hundreds, of other galaxies that were already well evolved may soon be proven has already been raised by certain study teams. This would demonstrate that the ancient galaxies were normal and not merely anomalies. Additionally, James Webb's deep vision only displayed a small portion of the early universe. We have to keep assuming that there were as many galaxies in the universe 13.6 billion years ago as there are now if the galaxies are verified. Thus, the Webb telescope's data demonstrates impressively that the early cosmos and our current universe do not appear to be that different. What thoughts run through the minds of scientists who consider the Big Bang to be an unquestionable fact? There are still those who believe that only our views on the formation of stars were incorrect, and that the previous theories are essentially right. This would still be conceivable in very few exceptional physical circumstances, but the chances are decreasing with each new Webb image. The discovery of protostars and infant galaxies must eventually be discovered if the Big Bang, which is thought to have occurred 13.8 billion years ago, is indeed true. However, astronomy will confront a significant challenge if the Webb telescope continues to reveal an increasing number of evolved galaxies and stars in the future. At a redshift of 20Z, some astronomers have already provided evidence of galaxies. This would imply that these galaxies were so near to the Big Bang that those who still believe in the previous theories of expansion and the Big Bang are no longer credible. If all of Webb's recent findings are accurate, they raise important issues regarding whether the cosmos actually has a beginning and how it came into being. Then the second major issue facing astronomy would be that there are significant mistakes in our physics that could have an impact on the entire field. We might have misinterpreted the light. Since our calculations are always based on the cosmos as a compact space and cannot be based on infinity, it is possible that they are incorrect. Or perhaps the actual mistake is a detail that we haven't even noticed yet. This aspect alone may indicate that the crisis opens up entirely new avenues for natural science and space exploration. Imagine that because our previous explanations are not working, we are now compelled to re-examine the regions where we have failed to see a force, or where the truth may be found in the enigmatic realm of particles. It may seem absurd, but a few hundred years ago, people believed that the Earth was the center of the universe. However, after a crisis, a completely different perspective emerged. Now the same event is very likely occurring once more. Although we believe that our cosmos had a beginning, the possibility of an infinite universe is currently growing. While many scientists are shocked by this, others are thrilled and eagerly await fresh theories and discoveries. The new thinking is already making an increasing number of new discoveries. While conservative scientists are still frantically looking for evidence of the Big Bang, the light signals of the oldest galaxies on Webb's pictures have been thoroughly examined by a team headed by Penn State University researcher Joel Ledger. The results of this investigation cast doubt on the notion of a youthful universe. The new telescope opens up amazing possibilities. Consider how Webb's tools might dissect old light into its component waves and record each one, revealing the precise elements that dominated these unfathomably far-off galaxies. Ancient cosmology relied heavily on the elements. According to the Big Bang and Dark Ages theories, star creation must have started with only light elements. Heavy elements entered the cosmos through supernovae only after the first protostars erupted, and the formation of galaxies as we know them now was only made possible by these heavy atoms. Helium and hydrogen are the light elements in space. The cosmos is supposed to have been dominated by these two. It's possible that heavier atoms like carbon, oxygen, and nitrogen were only introduced later. However, Webb demonstrates that heavy atoms were already present in galaxies near the Big Bang. They very certainly cannot be newborn galaxies based on this. Instead, the data indicate that the light we analyze today was released by galaxies that were already 4 to 8 billion years old. Thus, the genesis of these galaxies would go well beyond the presumed Big Bang. We may believe that it is more simpler now than the Big Bang was in the past, but it is not. From the Big Bang to the Dark Ages to the supposed expansion of the cosmos, the entire set of hypotheses is essentially a series of parallels. The theories are interconnected and complement one another. Additionally, all of these ideas and explanatory models neatly fit the widely accepted rules of Einstein's theories of relativity. Cosmology is based on Einstein's mathematical explanations of the forces and processes in the cosmos. To put it succinctly, there is nothing that doesn't fit into these equations. However, the Webb telescope's discoveries are now removing some cards from the cosmic deck. The likelihood of the construct collapsing is very high because we know what will happen at that point. These days, a lot of scientists are experiencing the same emotions as someone who has put a lot of time and energy into building a house. Sadly, they later had to acknowledge that the house was not as sturdy as they had thought. Natural science has the unique quality of being essentially only verifiable by actual observations. Everything remains only a theory as long as this actual evidence is absent. Obviously, no one has ever witnessed the Big Bang. For a long time, researchers likewise believed that this was impossible since there was no light at the beginning of the universe. We can only use our telescopes to view the light that has already passed through it. The fact that we can, in a sense, peer into the past is a lucky break. Naturally, the universe does not exist now as it did over 13 billion years ago. The only thing that shows us an imprint of the past today is how long it took for the light to reach us. Because of this, we have the rare chance to look back as far as there have been light sources. Officially, light that has traveled 13.5 billion years to reach us can be captured and shown by James Webb. The telescope can, however, record light that has traveled to us for 13.6 billion years, and perhaps even 13.7 billion years, as demonstrated by the first deep photos. Therefore, it will not be long until we are able to gaze back much farther. Maybe then we'll see the truth. There is still another little issue with the physics observations. A lot of observations that aren't totally clear-cut can be interpreted. No sharp galaxies are now visible to us at such a large distance. All we see are hazy spots of light that can only be deciphered by machines. We cannot understand what we observe with our eyes and brains. Here, mistakes can happen. For instance, it's not totally certain if some of the recently found light sources are the light of massive accretion disks surrounding black holes, or the light of galaxies. A comparable sensation might have been had by the astronomer Edwin Hubble, who around a century ago began to monitor the motion of very distant galaxies. These galaxies were traveling away from us and away from each other. According to Hubble's assessment, the concept of expansion resulted from this. The inflationary universe expanded the hypothesis in the 1980s. According to this concept, the cosmos experienced a period of extraordinarily rapid expansion right after the Big Bang. A universe that is extraordinarily homogeneous and uniform over great distances should have resulted from this inflation, which is also broadly consistent with findings of the cosmic microwave background. This fundamental radiation is thought to be an echo of the Big Bang and a type of fundamental data regarding all of the universe's motions and structures. Finally, both theories imply that the cosmos is large, uniform, and biuniform. Nevertheless, a growing number of events are increasingly showing that matter is not dispersed in space as uniformly as one might anticipate. We might be on the verge of another scientific house of cards collapsing and more interpretive errors. Hubble might have interpreted his observations and subsequent calculations incorrectly. This would imply that the fundamental assumptions underlying the Big Bang and expansion were already incorrect. Subscribe now to be part of every new video.